I am Priyanka Gupta, working as Assistant Professor at IARE in Computer Science and Engineering Department of Data Science. So we will again in next section of the data mining. So what is our new topic? Our new topic is data preprocessing. Let's get started. Today we are going to cover the contents are data preprocessing and overview, data quality, major tasks in data preprocessing, data cleaning, data integration, and the overall summary. We'll check. So why data mining? In data mining, what we are going to check while going into the data preprocessing process. Here we will measure the quality of data, whether the data is complete or not in some of way. When we'll go into the multi-dimensional view of the data, we will check here the accuracy. Here, while going into the pre-processing of data, we will check the measures of data quality, whether data is accurate, correct or not. We will check the multi-dimensional view of the data. So first we will going to check accuracy. We will check accuracy. Then we will check completeness. Completeness. Then we will check consistency. Consistency of the data. Then we will check timeline for the data. Timeline allotted for the data. Then we will check the believability of the data. And then we are going to check interpretability of the data. So I will tell these all terms in detail. So here we'll check accuracy of the data. The data is correct or wrong. The data before the phase pre-processing, we need to check the data is accurate or not. So we are going to check the data is correct or not. If whether the data will be correct, whether the data will be not correct. So we will check the both. After that, we will check the data is accurate or not. What is accurate? What we have taken the data that is near to the result or not. That is near to the result or not in the most accurate way. Then we will check the completeness. So we will check the data whether it is recorded or not. The source, like if we are taking from these some data from the different, like if we are taking the video type of data, so whether we will check the data is recorded there or not. The data recorded there or not. Again, for that we will check the data is if it is available or unavailable. So if that will not be unavailable, that so we will call that unavailable. Then we will check consistency of the data. So if we have modified that data in some of the way, then we will check the data has modified or not. And data dangling. If there is some changes in the data, that will come into the consistency of the data. Then timeliness, because whether we have taken the data that has been updated timely or not. The data that has updated or not. So we will also check in this process. Now we will check believability. What is believability? Whether the data we have taken that is from the trusted sources or not. Trusted sources. then only we are going to use that type of data. So before going for the pre-processing of the data, we will check why data mining. Why mining of the data before the pre-processing. Pre-processing process. Pre-processing process. So we will check the quality of the data. The quality of the data. So here we will check some of the measures. Some of the measures, what they are? They are accuracy, completeness, consistency, timeliness, believability, and interpretability. So we will now go into the brief. When we will see a multi-dimensional view of any type of data, so these are the measures we will check. We will check accuracy. So what is accuracy in terms of data? The data we have taken for the pre-processing, whether that data is correct or not. The data we are going to use is correct or not, because there may be some type of mistakes in that. There can be incomplete data. There can be missing data. There can be some type of this incorrect data. So we will check these measures for the accuracy of the data, whether the data is accurate or not. We will also check the completeness of data. What is completeness of data? The data, suppose for example, we have taken the data from the various sources like video or audio type of data. So we will check the whether this type of data is recorded or not. That is recorded or not. If that is not recorded, that will not be the complete type of data. So that data we have to exclude from our reprocessing process. So again we will check the data is available or not. If whether the data we have recorded is unavailable, then what we will do? We will not take that type of data. We will exclude the data for before preprocessing. So that is the use of preprocessing process. So again, next measure, we will check whether the consistency is there or not. What is consistency here? We will check here the data is modified or not. Modified and then it is recorded or not. If the data is modified and not recorded properly, so that is not a useful data. That will not be the useful data for us. So we will exclude that type of data. Inconsistency, the data dangling also comes. If some data has been modified, that is called dangling. So we will check for that also. Timeliness, whether the data, if we can say, if we are taking some data from the different social media channels, like if we can take example of YouTube. So if we have taken some data from the YouTube in the form of video, so we will check about whether the data is timely updated or not. The data timely updated or not. So that will be the timeliness of the data. So the data will be the complete data for our use. Complete data. That will be the complete data for our use. Then we will check the believability of the data. What is believability here? See, how trustable the data is correct. How trustable, the term. We will see in brief. What is trustable here? We will check the data sources. The data sources. From where we have taken that data, whether we have taken it from the trusted sources or not. That we will check in the believability part of the data quality measure. If that is not the trusted, then we don't believe the data, whether it is accurate or not. Next, we will check for the interpretability. We will check for the interpretability measure. How easily the data can be understood. What it means? What it means? Means how easily we can understand about the data. Whether the data is easy or not. Easy or not. So that will be their interpretability measure. So we have covered here the data quality measures. Data quality measures. So the next measure we will check timeliness. What is timeliness? Measure of data quality. So for example, if the data we have taken from the various social media channels, like if some data we have taken from the YouTube, for example, so we will check whether the data is timely updated or not. Whether the data timely updated or not. If that is not updated, that data will not be useful for our use. That data will not be useful for us. Next measure, we will check believability. Believability of the data quality. So, what is believability? I'll tell. How trustable the data are correct or not. Whether in this we will check whether the data is trustable or not. So we will check about whether the data has been taken from the trusted sources. If the data has been taken from the trusted sources, then the data will be, we can believe on. On that type of data only we can believe on. Right? So we will, if that source is not good, then we will exclude that type of data. Next measure is interpretability. Interpretability, how easily the data can be understood. So we will check in this process whether our data we have taken that we can understand easily or not. That data is easy or not to understand. So these were the some measures to check data quality for the data mining before data pre-processing. Next, major task in data pre-processing. So while we are going into pre-process the data, what are the different phases are there? The data cleaning. First is data cleaning. Second one is data integration. Data integration. Data reduction is the third process. Data transformation and data discretization is fourth point. Data transformation and data discretization is fourth point. So we will go into the brief of them now. Data cleaning. So in this part of data checking, data quality checking, we will check if the data is having missing values or not. If we are having, suppose for example, if we are having some structured data in the form of table, in the form of table, and we are having some records. We are having some records. Okay, we are having some records. So if some of the field is missing, it is not having any value. It is not having any value in some part of the record. If in some part of the record, so that type of data we have to fill. So we have to fill before data pre-processing that missing values. So there are some methods to fill that missing values. I'll tell. So some methods are to fill that type of value, missing value, is we can take the average of the whole column. We can take the average of the whole column. And second is we can take like if the some value is redundant, we can take to fill that missing value. We can take to fill the missing values. So for this type of missing value examples, we can fill that missing value from the record, for the record or table. Next is smooth noisy data. So what is this? Noisy data. So noisy data is nothing but the data with some part of the data with some noise. Inconsistency. Data with inconsistency of the data. So that type of data we have to smooth that type of data. So we are also having some methods to smooth that type of noisy data. Next is identify or remove outliers. So what are outliers? I'll tell. If we are having some of the data records or some of the data sets, so how we can see data outlier? Data is the outlier. So within the range, if we are taking some range, within the range, the data is not the outlier. So without exclude from this range, the data is called outlier data. So data is called outlier data. So what we will do? We will remove that outlier from the data. That useful data. Next is resolve inconsistencies. So that was nothing. Inconsistency is nothing but inconsistency data. That is nothing but inconsistency in data. So we have some methods to resolve that is a type of inconsistency. So we will apply that type of data. So all of these steps comes under data cleaning part of the data. Next is data integration. What is data integration? So if we are having some databases, because any data we are taking from any data sources, so that data must be stored in some databases. So what we will do? If we are having some many databases, more than one databases, so what we'll do? We will integrate that type of multiple databases at one place. We will integrate. We will store that all we will store all multiple databases at one place. So data cubes. What is data cubes? Cube is nothing but the logical view of that type of data that comes under data warehouses. So we will store that multiple type of databases at one place. So that comes under data integration, because we are having huge amount of data. We are having huge amount of data for data pre-processing. Because then the data mining comes. So we will integrate that all the databases at one place. Next comes data reduction. What is data reduction? Data reduction is nothing but we have to reduce the data for our use. There are some methods to reduce that type of data. So what are the methods? We are having dimensionality reduction. So data must have some dimensions, some type of dimension like 2D or 3D. So that type of data, if we are having 3D data, then we need to reduce in 2D data. Then we can work on that data. Numerosity reduction of data. That is another method for the numeric type of data. Next is data compression. That also comes under the data reduction. Then we are having method data transformation and data discretization. What is this? In this, we need to transform one type of data into another type of data. In this, we change the form of data. So that comes under data transformation. For that, we are having some methods that are called normalization and concept hierarchy generation. So these were the some major tasks in data pre-processing while we are starting data pre-processing of any data set. So we will take first of that, data cleaning. So data in the real world is dirty. Nowadays we are having huge amount of data in our surroundings. So can we say that all type of data is useful? No. All the type of data is not useful. There are some dirty data also available. We have to fetch that information, the useful data, from that huge amount of data. So that we are calling data in the real world is dirty. So much data is available nowadays. So lots of potentially incorrect data, we can say instrument faulty, human, a computer error or transmission error data is also available with the good amount of data. So we will check in brief what are these type of data. First, incomplete. Second, noisy. Inconsistent. Intentional. What is incomplete data? Incomplete data is lacking attribute values. If we are having some type of attribute, some type of data which also lacking the attribute values, this we can call missing values. If some missing value is there, So that we call as incomplete data. Incomplete data. Lacking certain attribute of interest. If we have to use some part of data, if you are having huge amount of data, see, if you are having huge amount of data, from that we need to only use some type of data. So if we are lacking, if we are not having that type of data, that is also the incomplete data. That is also the incomplete data. Or certainly only aggregate data. What is this aggregate data? That containing only aggregate data. The data, if we need some type of fields, some type of data, if we need some type of, for example, we are having some structured data. If we need for some type of columns, particular columns, and that are only in one column aggregated, so that is also not useful for us. That we call as incomplete type of data. So that also comes under the incomplete data. Here, for example, occupation. If somewhere occupation is equal to, written like this, occupation is equal to space, double quotes, space. So that is we call as incomplete missing data. That is missing data actually. So that comes under incomplete data. Incomplete data. Next is noisy data. That is containing noise, errors and outliers. So we have already talked about the outlier. So outlier is nothing but within the range, what is the data we required, that is excluding that type of range. So that is called as outlier from the data set. So this type of data, if we are having, so that comes under the noisy type of data. For example, if you are having salary, if you are having some attribute salary is equal to -10, and we need to get at salary is equal to 10. If we need salary is equal to 10, so that is also comes under the error. That part comes under the error. So that is also the noisy data. Next is inconsistent data. So inconsistent data containing discrepancies in codes or names, that having discrepancies. So we will check for the example. For example, if age is equal to 42 and birth day is equal to 3, 7, 10. So that was rating as the 1, 2, 3. That was rated earlier as a 1, 2, 3. And that has been changed as A, B, C. The rating has been changed as A, B, 3, C. So that is the discrepancy. That is the discrepancy between the duplicate records. So that is the duplicate of that. That record is duplicate of that. So that comes under the inconsistent data. If some data has been changed, has been modified and not accurately written as earlier, so that is called under the discrepancy of the data. Next is intentional data. So what is this type of data? Disguised missing data. If some missing data is there in our data, that is not visible to us in any form, so that comes under the intentional data. For example, January 1 as everyone's birthday. No, because now not everyone's birthday comes on 1st January. So that is also the intentional errors. So that was the some errors come under the data cleaning. Whether we are going to clean the data, this type of data is available to clean from our side. So we will get into the all the data in one by one. Incomplete or missing data. Incomplete or missing data. The data is not available always. The data is not available always. For example, many tuples have no recorded value for several attributes, such as customer income in sales data. If we are having sales data and we are having missing customer income, so that is called as missing data, missing or incomplete data. Second is missing data may be due to some of the measures are there why the missing data is there. Equipment malfunction, some equipment malfunction should be there. If we are saving from any places, the system is not working or any type of malfunction is there, then the data has been missed. The data has been missed. That has not stored properly. Inconsistent with other recorded data and then deleted. The data was earlier inconsistent, that was not correct, incomplete, and that has been saved with the another type of data and then it has been deleted. So that also comes under the missing data. Data not entered due to misunderstanding. So while we are humans, if we are not saving or working properly on some type of data and not saving in a proper way, so that data can be misunderstood. So that also comes under the missing data. Certain data may be considered, some data may be considered important at the time of the entry. While we are entering the data, then only we find that is useful. So we have not recorded properly that type of data. That also comes under the missing data. Some of data not registered with the history or changes of the data. Some data we have changed and that has been not properly stored on the some sources. That has been not properly stored on the sources. Missing data may need to be inferred. So these were the some detailed examples of incomplete or missing data. How to handle missing data? So let's discuss about how we are going to handle those type of missing data. So what we will do? We will ignore the tuple. First, we will ignore the tuple. What is tuple? Tuple is nothing but while we are having some structured data, a tuple is nothing but this field. That is called tuple. So we have to ignore that tuple. We have to exclude that whole of the record. For that tuple, we need to exclude whole of the record, for example. So that is, we are going to ignore the tuple. Usually done when class label is missing. When doing classification, we are having some method classification and we are not having the proper label. This is the label and the data comes, some of the data comes under this. Like if we are having name field, okay, we are having name field and we are having some examples of names and the name that has been missed. So all the data will not be useful for us. So usually that will be not effective when the percentage of missing value per attribute varies considerably. So how to handle missing data? So first example is ignore the tuple. What is tuple? For example, if you are having some structured type of data, we are having some table, structured table. So the tuple is nothing but the record in row and column. The record is stored in the row and column. So that is called tuple. So what we will do? We will exclude that tuple while we are going to pre-process. Before pre-process data cleaning, we are doing data cleaning. So we will exclude the tuple. We will ignore the tuple. Usually why we are going to do that? When we are having some classification method, if we are having, for example, we are having some field name, and we are having some names in the table. So if the classification, the name is deleted somehow, if name is not there recorded, so we will ignore the all of the tuple. We will ignore the all of the tuple while doing classification. So that will be not effective when the percentage of missing values or attribute varies. When the missing value will be very that will be large in number. If missing value will be large in number, so that the data will be not effective. If we will exclude that whole data, if we are having some, for example, we are having 20,000 record, and we have missed that name label, and we are having some, we can say 1,000 missing values are there. So we have to ignore that all tuple. So if we will use that data without the name class label, so that data will not be useful for use. That data will not be useful for our use. If name class label is not there, so that, because every data dependent, every of the column depend on the other. So if that is only when we will exclude, when we will ignore the tuple, only when missing values is not much more. Second is fill in the missing value manually. So that is another way to exclude the missing values. What we will do? We can say, for example, average method is there. We can take average of the all of the records, and then we can fill the missing value with the average of that. Average of the value. If missing value is there. Second, what we will do? There are some other methods also. I'll tell in brief. So we have to fill the missing values with some of the values for the sake of data cleaning. So is this tedious or infeasible? Yes, that is also tedious job and infeasible job while doing the filling the missing values. So, third way is filling it automatically. We will fill automatically with the global constant that is unknown, a new class, attribute mean. The attribute mean. So mean is nothing but average. It will be filled automatically. The attribute mean for all the samples belonging to the same class. So that is another good example. That is another good way to fill the missing value. Fill the missing value automatically. Another example is the most portable value. That is, some methods are there, inference based, such as Bayesian formula or decision tree. So we will use that Bayesian formula and decision tree to fill that missing value to use that data. Use that all the data. Noisy data. So what is noisy data? What is noise actually? Noise is nothing but random error, a variance in a measured variable. That is nothing but random error. Random, that the error comes randomly, that is called noise. Incorrect attributes values may be due to fault data collection, instrument, data entry problems, data transmission problems, technology limitation, inconsistency in naming convention. So these are some incorrect attribute that can be happen by these. That can be, the noise can happen by these attributes. These some of the attribute. Other data problems which require data cleaning, that is duplicate records, incomplete records and inconsistent data. So that is also needed to replace with the some useful type of data. So that all comes under the noisy data. How to handle noisy data? How to handle noisy data? So there are some methods to handle that noisy data. First is binning. First, sorted data and partition into equal frequency bins. If we are having some data, we have to partition that data into sum of 1 to. If we are having some data, we have to part that data, and then we have to first sort that data. What is sorting? In the alphabetically order. Is it ascending or descending? We have to sort the data, then we have to part the data. We have to do partition of the data in the equal bins. What are bins? Bins. Bins are nothing but the sum of the storage of the some data. Bins are nothing but the separate bins of the data. Separate bins of the data. Then what we will do? Then we will smooth that data by bins. Means smooth by the bin median. We will take median of the bin. We will take the median of the bin. We will take the boundary of the bin. So these are the some statistical measures, central tendency measure we have to take whether we are creating bins before to handle the noisy data. So what is median? What is median here? Median is the central tendency measure to measure the average, mean of the some type of data. So we have to take the bin median. We have to take the boundary of the bin. While we are created some bin, so we have to take the boundary of the bin. Second method is regression. What is regression? Regression is nothing but smoothing the data by fitting the data into the using with the functions. There are some regression functions. We have to fit that type of data with the use of that regression functions. So that comes under the regression of the data. Clustering. That is the third method. We have to cluster the data to detect and remove the outliers that we have discussed already. So we have to detect and remove that type of outliers with clustering method, with the use of clustering method. Another method is combined computer and human inspection. So that is nothing but manual inspection of the computer and human. That is nothing but combined computer and human inspection. So in that we have to detect suspicious values and check for the outlier, whether outlier is there or not. So that is a manual way to check the noisy data. So we have checked the various methods to handle the noisy data. Now data cleaning as a process. So what is all the process behind data cleaning? data discrepancy detection. Data discrepancy detection. So while we use metadata like domain, range, dependency, distribution, in that we are having data discrepancy detection. We have to check field overloading. We have to check field overloading. We have to check uniqueness rule, consecutive rule, and null rule. So to detect any type of discrepancy, we have to check uniqueness, consecutive rule, and we have to apply null rule. Whether we are using in commercial tools, like we are having some data scrubbing tools, data auditing tools also to check whether is data discrepancy there or not. So what is data scrubbing? Data scrubbing. Here we use simple domain knowledge, that is postal code or spelling mistake, for detecting any type of errors, and we will do the corrections. So that we will use by data scrubbing tools. Data auditing. In this, by analyzing data to discover rules and relationship to detect violators. That is correlation and clustering to find outliers. That is nothing but correlation and clustering to find outliers. Next is data migration and integration, in which we are having some tools like data integration tools, data migration tools, and ETL tool. That is nothing but extraction, transformation, and loading process tools. So data migration tools we are using to allow transformation to be specified, transmission to be specified. ETL tool, that is used for allow users to the specify transformations through a graphical user interface. For that we are using ETL tools. Next method is integration of the two processes, that is iterative and interactive. That is interactive or iterative. For example, Potter's wheel. In this we have to integrate these two type of processes together. Data integration. So what is data integration here? That is another process before data preprocessing. So data integration, nothing but that combines the data from multiple sources into a coherent store. The data has been combined at one place, combined at one place, that comes under the data integration. So here schema integration. For example, if we are having a query, a dot cust id, and aggregating with b dot cust dash, we are having hash. So that is nothing but these are two schema we are aggregating at a one place. If we are having knowledge of database, so we can understand that what is schema. So we are having two schema here, and we have to integrate at one place. Integrate metadata from different sources at one place. Entity identification problem. So identify real world entities from multiple sources. For example, Bill Clinton is equal to William Clinton. For example, if there is a query, Bill Clinton is equal to William Clinton, so we have to integrate that type of data. If they are same, we have to integrate that data at a one place. We have to use one data. We have to replace that data at a one. Next is detecting and resolving data value conflicts. Detecting and resolving data value conflicts. For the same real world entity, attribute value from different sources are different. Possible reasons. different representatives, different scales. So that type of variety comes under like this possible regions. These are the possible regions. For example, metric versus British units. Metric versus British units. So these are the possible regions that can be changed. Metric rule can be changed, and British have their own units to measure any type of quantity and the thing. So that is the possible region that has been integrate that we have to integrate at a one place. Handling redundancy in data integration. So while we are having data integration, we also have some duplicate data. We also can have duplicacy of the data. We can have a copy of same data at two places and many places. So what is this? We have redundant data occur when integration of multiple databases having. So that are having object identification, that is the same attribute or object may have different names in different places, different databases. Derivable data. One attribute may be derived attribute by the other table, that is annual revenue. If we are having same attribute from the another table, that is also comes under the redundant data. Redundant attribute may be able to detect it by correlation analysis of the covariance analysis and the covariance analysis. These are the two methods to detect that type of redundant data accurately. So careful integration of the data from multiple sources may help reduce and avoid redundancy and inconsistency and improve the mining speed and quality. So if we will remove that type of missing data, we will integrate that type of data at a one place. So we will be able to improve the data mining speed also and data quality also. So that was the handling redundancy data integration. So in earlier slide, what we have taken correlation analysis. So that only will be applied on the nominal data. Nominal type of data that only can be applied. So what is nominal data? Which are having numeric type of data. So on that we will apply that type of data. So for correlation analysis, we are having chi-square test. That is statistical test whether to use to check the redundancy of the two data. So the formula for chi-square is summation of observed values and expected values, and observed value minus expected value, square of that data upon expected value of the data. So that is the test chi-square test formula. So the larger the chi-square value, the more likely the variables are related. If we will get the larger amount of the chi-square value after this formula, then only we will get to know the variables are likely to the related, that are more related, that are correlated. The data is correlated. So that is the one point to check whether the data is correlated or not. The cells that contribute the most to the chi-square value are those whose actual count is very, very different from the expected count. So that is, that is very different, then only from the expected value, that only can contribute the most to the chi-square value. So only we can have the larger value of the chi-square. So the correlation does not imply causality. For example, all of the hospitals and all of car theft in a city are correlated. That is example in some type of structured table. So that hospitals and car theft in a city are correlated. So that we can say is the data is correlated. So the chi-square value will be larger if they are correlated. Second example is both are causally linked to the third variable, that is population. So the population also is for the car theft in the city and number of the hospitals, that is same. So we will correlate that two type of data together. So that was the correlation analysis formula for the nominal data. So here we will take an example of that chi-square calculation. So if we are having this table, in this table we are having play chess, not play chess, and some of these two as a column, and in a record we are having like science fiction, not like science fiction, and some of these columns. Here we are having 250, 200. The sum of these are 450. Here we are having 50, 1000, and some of these are 1050. And here we are having the sum of that total is 300, and here 1200, and all of the total is 1500. So that is a table to calculate the chi-square value. So chi-square calculation, numbers in parentheses are expected counts and calculated based on the data distribution in two categories. How we will take? 250 minus 90. 250 minus 90. So that is expected value. 250 came, and what are the expected value? 90. So we'll minus from that, square that upon 90. What is the expected value? Again, for each quantity, we will repeat the same. 50 minus 210, square of that upon 210, plus 200 minus 360, square of that upon 360. Again, we will have 1000 minus 840, square of that upon 840. So we will calculate all of these, and we will get 507.93. The value we will get 507.93. This is the chi-square value, that is. So we can say the play chess and the not play chess is more of the correlated. It shows that the like science fiction and play chess are correlated in the group. Yes, we can say play chess and the not like, that is that this is more correlated in a terms. So that was the example for to calculate the correlation value. That is nothing but chi-square value. Correlation analysis for the numeric data. Correlation coefficient, that also called as Pearson product moment coefficient. So what is the formula for that? Coefficient of AB is equal to summation of n to I is equal to 1, AI minus A bar, BI minus B bar upon n minus 1, sigma A, sigma B. That is the formula for to calculate the correlation coefficient. So where n is the number of tuples, A bar, B bar nothing but are the respective means of the A and B, and sigma A and sigma B are nothing but are the respective standard deviation of the A and B. Standard deviation. What is standard deviation? That is in statistical means, that is the standard deviation of the two standard deviation of for the used for the central tendency measure. And here, what is sigma? Sigma AI BI is the sum of the AB cross product. If RA and B will be the greater than the 0, A and B are positively correlated. A's value increase as B value also increase. The higher, the stronger correlation exists. then RAB is equal to 0, then it will be independent. RAB less than 0, it will be negatively correlated. So this is the formula to calculate the correlation coefficient. Here we can see the visually evaluating correlation. Visually correlating evaluation. So here we can say this in this graph, these are the most correlated values. These are the most correlated values. In each of the fields which are more closer, in each of the graph that values are more closer, that is the more correlated to each of them. More correlated to each of them. So these are the graph for the positively, negatively correlation, to check the positive and negative correlation. So scatter plot showing similarly from -1 to 1. That is -1 to 1. That is -1 to 1. So correlation viewed as linear relationship. When we are taking some of the fields as a linear relationship, then correlation measure the linear relationship as an object. To compute that correlation, we standardize data objects A and B and then take their dot product. So this is the formula we are going to calculate the correlation for B of A and correlation. This is the formula. Correlation of A and B will be the nothing but as the dot product of the both of the standardized data object. These are the data objects for the linear relationship. Covariance. So covariance analysis for the numeric type of data. Covariance is similar to the correlation that we have taken. There is a formula, covariance of A and B, that is E is equal to A minus A bar and dot product B minus B bar. So the formula is summation n to I is equal to 1 AI minus A bar and BI minus B bar upon number of values. So correlation coefficient R of AB is equal to covariance of AB upon covariance of AB upon delta A delta B, sigma A sigma B. So where n is the number of tuples. This is the number of tuples. A bar and B bar are the respective means, respective and expected value of the A and B. And sigma A and B are the respective standard deviation of the A and B. Standard deviation of the A and B. So here also the positive, negative and independence covariance exists. So what is positive covariance? If covariance of A, B is greater than 0, then the A and B both tend to be larger than the expected value. When the negative covariance exists, if the covariance of A and B is less than 0, then the A is larger than the B, likely to be smaller than the expected value. Independence covariance, when the covariance of A and B is equal to 0, then the converse of the will be the not true, that will be the untrue. So some pairs of random variables may have a covariance of 0 but are not independent. So under some additional assumptions, for example the data follow multivariate normal distribution. That does a covariance of 0 imply independence? That imply independence. Covariance of 0, what is it? It implies independence. So that type of covariance comes under the independence covariance. So these were some examples of covariance for the numeric data. Now we will have an example for that and we will check. So the formula we have already checked. So it can be simplified in computation as covariance of A and B is equal to E of A dot B minus A bar B bar. So for suppose example, we are having two stocks of A and B that having that are having following examples, following values in that. For 1 week, 2, 5, 3, 8, 5, 10, 4, 11 and 6, 40. So if the stocks are affected by the same industry trends, will their prices rise or their prices will be fall together? So that we have to check. So we have to calculate E of A and E of B first. So for calculating E of A, we will segregate. We'll add 2 plus 3 plus 5 plus 4 plus 6 divided by 5. There are 5 stocks. So we will divide upon that. So that will be 20 upon 5. That will be 4. E of B, similarly, we will calculate 5 plus 8 plus 10 plus 11 plus 14 divided by 5. That is nothing but 48 by 5 is equal to 9.6. 9.6. So we will calculate covariance of both A and B together. So what will be that? That will be 2 into 5, 2 into 5, 3 into 8, 5 into 10, 4 into 11, 6 into 14 divided by 5 minus 4 into 9.6. That is 4 and 9.6. So covariance comes 4. The covariance comes 4. So A and B rise together because covariance of A and B is greater than 0. That is 4. 4 is greater than 0. So that the A and B will be rise together. From the example, stock will be rise together. So for this, by this formula, we can calculate the covariance of the some values. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.